Hello, everyone. Welcome to the video lesson for Monday, February 22nd and Tuesday, February 23rd. In today's classes, we started off with a warm-up all about molar mass. Remember what we did back last Thursday and Friday. Then we moved on and continued on with our gizmo, activity B, mass and mole conversions. And then we took some notes on factor label method for conversions, also known as dimensional analysis. Your homework between now and when I see you next is to work on your gizmo, activity C. So our warm-up today asks you to find the molar masses of CaCl3 and NH5,3N. And I should warn you, I did Google proof these. If you try to Google this, it's going to try and correct you since these are kind of impossible molecules. So you got to try and you got to go through those motions. Remember our rules for finding molar mass. Look up the molar mass of that individual element, multiply it by how many there are, so the subscript. Do that again for all the other elements, and then add them all together. So my first one here, I've got CaCl3. So my first element is calcium, Ca. If I look it up on the periodic table, I can see that its molar mass is 40.08 grams. And if I look at my formula, I only have one. There's no subscript. So 40.08 times 1 gives me a total of 40.08 grams that my calcium is bringing to this compound. And then I've got Cl. I've got my chloride. Cl. If I look up my chloride, I can see that its molar mass is 35.45 grams per mole. And then I've got a subscript of 3. So I have 3 of them in this. So I have 35.45 times 3. That gives me a total of 106.35 grams. So to find my final molar mass of CaCl3, I just need to add these together. 8 plus 5, 13, 1, 4, 6, 4, and 1. So my molar mass for calcium chloride, CaCl3, is 146.43 grams. Next up, I have NH5,3N. So my first element here is my nitrogen. So if I look up my nitrogen, its molar mass is 14.01 grams. And my total number of nitrogen atoms, well, I have NH5 3 times, so that's 3 nitrogens, plus the one on the outside. So I have a total of 4 nitrogen. So 4 times 14.01 gives me a total of 56.04 grams. Then my next element is hydrogen. If I look up the molar mass of my hydrogen, it is 1.01 grams. And then I have 5 hydrogens here in NH5, and I have NH5 3 times, so 3 times 5 gives me a total of 15 atoms. So I have 1.01 grams times my 15 atoms gives me a total of 15.15 grams. So I'm going to add these two together. 9, 1, 1, 3 the 1, 7. So my molar mass of NH5,3N is 71.19 grams. Remember, anytime you work with molar mass, you want to round to 2 decimal places. That way we'll all keep getting the same answer. After we finished with the warm-up, I asked everyone to please open up their Activity B, Mole Conversions Gizmo worksheet. We started working on this one on Thursday and Friday of last week. On Thursday and Friday, we got through page 1. We started with 2 moles of carbon, and we use the molar mass to convert 2 moles of carbon into 24.02 grams. Now, a new strategy that I introduced today was to highlight your given amount. So every time you have a question, especially a conversion question, you'll be given a number, a unit. If we were in class, I'd ask you to take out a highlighter or to underline it with a pen or a marker. Now that we're here in digital class, we can just highlight it in the document, come up here, and choose any highlighter color that we want. I chose green because it's kind of a fun. So as we started on today, we started on page 2, question A. Now we were told to reset the program for 46 grams of carbon, and we wanted to know how many moles this. So once again, I highlighted 46 grams of carbon. That's our given. I highlighted it green. And whatever it is that we're given, those units, that's what you want to start with in your problem. So if I have 46 grams, and I know that they are 12.01 grams in every 1 mole, I know I can easily divide 46 by 12.01, and my calculator will tell me I get 3.83. So I want you to look real quick. I've got grams, and then I'm dividing by grams. So I want you to think back in your math class. If you had something like 1x over 2x, what would happen? You'd end up with 1 over 2. Your x's would cancel out. The same thing happens with my units. I have grams on top divided by grams on the bottom. So my grams cancel out. That's why there are no grams in my answer. Now what happens to moles is a little bit stranger. I've got grams divided by grams divided by moles. So the weird thing that happens is that actually pops moles up to the top of the numerator. So I actually end with a unit of moles. It's a little bit weird, but it makes a little bit more sense when we do it with our factor label grid. Next, it asks us to check our answer. So here I have 46 grams of carbon atoms on my balance. We've calculated that it will be equal to 3.83 moles. So the next question is asking us, how many mole jars do we think will be filled by this? Well, there are several very good answers to this question. We know that there are 3.83 moles, or at least there should be. Each of these jars holds 1 mole. You could say that it's going to fill 3.83 jars. You could say that it's going to fill 3 jars completely with 1 jar and a little bit extra. Or you could say that it's going to fill 4 jars. Just understand that that 4th jar won't be completely filled. So now the gizmo asks us to fill these jars to see how many moles there are. There's 1 jar filled, 2 filled jars, 3 filled jars. So the gizmo seems to agree with our answer. 3.83 moles were in that 46 grams of carbon. Next, I gave you a chance to solve a very similar problem with iron 2 chloride. So the first question was, what is the molar mass of iron 2 chloride? You can use your periodic table to find the masses, add them up, and you get 126.75 grams for every 1 mole. Then it asks you to find how many moles are in 151 grams of iron 2 chloride. So again, I asked everyone to highlight their given amount. So I highlighted my 151 grams of FeCl2 green. Then when I did my work, that's what I started with. You always start with what you're given. So I started with 151 grams. I know that every 1 mole has 126.75 grams in it. So I divided my given by my molar mass. Again, my grams cancel each other out. My moles jumps up to the top of the problem. And I'm left with 1.19 moles. So now let's see if the simulation agrees. We calculated that 151 grams of iron 2 chloride should equal to 1.19 moles. So let's see. That's one filled mole jar. There we go, 1.19 moles. That agrees with the answer we found. Next, the gizmo wanted us to reflect. It wanted us to summarize, how did we solve these two questions? So first, in question number 1, using molar mass, how did we convert between moles into grams? In question number 1, we were given moles and we multiplied by the molar mass. So we had 2 moles and we multiplied it by 12.01 grams per mole. That gave us our final answer of 24.02. Our moles were being divided by moles, so they canceled out. So we have no moles in our answer, and grams are left as the only units. Then, using molar mass, how did we convert from grams to moles? In questions 2 and 3, we were given the starting amount of mass, and we wanted to find how many moles there were. So we took our given mass, and we divided by the molar mass. This way, our grams were canceled by grams, and our moles were the units that were left. Now, the rest of our classes didn't get much further than that, but I'd like to go a little bit further since this is our video lesson. The next question, number 4, is now working with the number of a mole. So how many atoms are there in 1 mole? Well, that was a big chunk of our lesson on Friday. A mole is 6.02 times 10 to the 23rd. So how many atoms are in 1 mole? There would be 6.02 times 10 to the 23rd atoms per mole. Just like I wrote our molar mass as grams per mole, I've also written this as atoms per mole. Then it asks us, how many atoms are in 2 moles of sulfur? So 2 moles of sulfur is our given. So that's what I start with in our equation. If I know that there are 6.02 times 10 to the 23rd atoms in every 1 mole, that means I want to multiply if I have 2 moles worth. So I have 2 moles multiplied by 6.02 times 10 to the 23rd. And my answer is 1.20 times 10 to the 24th power atoms. Notice I have moles and divided by moles, so my moles cancel out, and my atoms are the units that are left over. Now you can show your exponents in 2 different ways. You can highlight them, and you can change into subscript. Or in my answer here, I have that little up arrow. That's above the 6 on your keyboard, so you can use that to show that something is an exponent as well. So if I drag these mole jars over to my atom counter one at a time, it is counted 1.20 times 10 to the 24th atoms. This agrees with what we calculated. And the last one I'm going to work on here with you guys in this video lesson is question number 5. So now in question number 5, I have 1 times 10 to the 23rd atoms of sulfur. And I want to know how many moles is this. So my given is 1 times 10 to the 23rd, so that's what I start with. If I know that there are 6.02 times 10 to the 23rd atoms in every 1 mole, I need to divide. So I have 1 times 10 to the 23rd atoms divided by 6.02 times 10 to the 23rd atoms per mole. My atoms cancel out my atoms. I can put this into my calculator. Be very careful with those parentheses. And I get a final answer of 0.17 mole. The next question asks, is this more or less than 1 mole? I hope we can all see that 0.17 is less than 1. And before we even do this calculation, we should have been able to tell that we were going to end up with less than 1 mole, since 1 full mole is 6 times 10 to the 23rd. And here we were given 1 times 10 to the. So I'm hopeful that most of you guys would have seen that it was going to end up to be less than 1 mole. So I have my 1 times 10 to the 23 atoms in the atom counter. So if I put a jar underneath it, I get 1.7 moles of sulfur. This does not completely fill our jar, and I only get 1.7 cup, and I only have 0.17 moles of my sulfur. If you would like help finishing this document, please come and see me or any other chemistry teacher during our student support period or during Wednesday check-ins. We'd be more than happy to finish going through this document, but this is as far as we're going to go in class and in the video lesson. So how we solve for moles and grams and atoms in the gizmo is one way, but it involves a lot of memorization. You'd always have to memorize that anytime you went from grams to moles, you'd have to divide. And anytime you went from moles to grams, you'd have to multiply. You'd have to memorize when to multiply and when to divide. I don't want you guys to have to memorize anything. I want you guys to be able to use the tools you're given to solve for problems. So factor label conversions, also known as dimensional analysis, is a much simpler way to do any sort of conversion, no matter what you're converting between. There's 2 things you need in order to do factor label. The first is an equivalency statement. Equivalency statements go ahead and show us how 2 different units are related. So some examples that were already in the box are 1 minute is the same as 60 seconds. 1 inch is the same as 2.54 centimeters. 1 meter is equal to 100 centimeters. In our gizmo, we used a few different equivalency statements. We had our molar mass. So 1 mole of carbon was equal to 12.01 grams of carbon. 1 mole of iron 2 chloride was equal to 126.75 grams of iron 2 chloride. We also had 6.02 times 10 to the 23rd atoms are equal to 1 mole of atoms. A conversion factor is just taking that equivalency statement and writing it as a fraction. Either way it works, it doesn't matter who's on top or the bottom. Either way, it's still a true statement. It is still equal to one thing. So 100 centimeters divided by 1 meter describes the same length as 1 meter over 100 centimeters. We can do the same with our molar masses. 1 mole of carbon over 12.01 grams of carbon, or 12.01 grams of carbon over 1 mole. What matters about which unit is on top and on bottom completely depends on what unit is in your given amount. Remember, I said you should always highlight that given amount with its unit. Now, it's going to be pretty hard to type some of those into your notes. So if you go to your past lessons page where this video is currently embedded, you will see that I posted this image. So you can quickly copy that image off of that page and paste it onto your Google Slides. On the next slide, I have an example of how you set up any factor label conversion problem. Now, this is a one-step conversion, but the wonderful thing is with factor label, you can do a one-step conversion just as easily as you can do a 3, 4, 6-step conversion problem. All you have to do is know how to set it up. So you always start with your starting unit, your given amount with that given unit. That goes in that first box. That's what you always know. You can stop reading the question right then and there for a little bit, because that first unit tells us a lot. Whatever that unit that you start with is, it is trash. It is garbage. You don't want it. You're getting rid of it. So you put it on the ground. You put it on the bottom of the grid. So the conversion factor with the starting unit is what goes on the bottom of your factor label grid. You want to match those units diagonally so they cancel out. Now, what you're converting to, what you're being asked for in the question, well, that's something special. That's something nice. You like that unit. You should put it up somewhere high, somewhere nice where everyone can admire it. So the unit you want to end with is a unit that goes onto the top. So you're canceling out what you don't want by dividing it, and you're keeping what you want by multiplying it. Once you have your correct units into your factor label grid, then I tell students, then you should put in the values. Then everything across the top you multiply. Multiply every single thing on the top of your grid. Right now, with the problems we did today, it's never more than just 2 numbers, but you could have as many as 5. And then one at a time, divide by the values and units on the bottom of the grid. Once you've finished, if you've done this correctly, the units you no longer want will be canceled out, and the units you do want will be the only ones left. And on our last slide of these notes, I have those same problems we just did in the gizmo, but done with the factor label method. Now, I made 2 small mistakes. I forgot to type in your equivalency statement. Remember, you always need an equivalency statement anytime you're doing a conversion. So the equivalency statement we used for those 2 carbon questions was 1 mole of carbon is equal to 12.01 grams of carbon. So just make a little text box and enter that into your slide. I put it in between the 2 problems because it's used in both of these problems. The other small mistake I made is I flip-flopped the order you got these questions from your gizmo. We actually did the 2 moles of carbon into grams first. So here's our question from the gizmo. We were given 2 moles of carbon and asked for the number of grams. So my given amount was 2 moles of carbon. Then my equivalency statement, I used the molar mass. Here's my molar mass. So here, if I start with moles, I want moles on the bottom, so they cancel out. So I've crossed them out. My moles are equal to grams, so I put grams on top. And I solved it the same way I did in the gizmo. I have 2 moles times 12.01 grams. So that gives me 24.02 mole grams of carbon. Then I divide it by 1 mole of carbon. My 24.02 stays 24.02 when divided by 1, but the mole carbon divided by mole cancels out those moles, so I'm only left with grams of carbon. Then the second question we did in the gizmo, I was given 46 grams of carbon and asked to find the number of moles. So my given amount here was the 46 grams of carbon. Since I started with grams of carbon, I wanted to divide by grams of carbon. So I put those on the bottom. And since one is on the bottom, one is on the top, that means moles goes onto the top. So here I have 46 grams times 1 mole. So that gives me 46 mole grams. Then I divide it by 12.01 grams. So my grams cancel out. And I really, at that point, have 46 moles divided by 12.01, which gives me that same answer of 3.38 moles. Notice, I'm doing the same math I did here, but I've just reorganized it slightly. When you use factor label, you don't have to memorize when you multiply and when you divide because I'm dividing and multiplying both times. The only thing you need to figure out when you have a factor label problem is what unit to put on the bottom and what unit to put on the top. Whatever unit you start with is the one that goes on the bottom, and the unit you want to end with is the unit that goes on the top. Your homework, Gizmo Activity C, is in the same Gizmo we've been using, but now you're using that third tab that says Dimensional Analysis. So you're going to be using Dimensional Analysis or Factor Label to solve a series of questions. I will help you start to answer the first one. The first question is, how many grams are in 3 moles of carbon? So here in the Gizmo, I've been given 2 different conversion factors. I have 1 mole of carbon is equal to 6.02 times 10 to the 23rd atoms of carbon. And I have 1 mole of carbon is equal to 12.01 grams of carbon. So let me look at my question again. I want grams and I have moles. So I don't need that first one. I need the second one, moles and grams. So I'm going to click on this tile and bring it down to the problem. Oh no, doesn't make much sense. The way I've set this up, since I have my show units on, that's going to give me moles squared divided by grams. This isn't set up right. Notice I start with moles. So if I start with moles, that's garbage, that's trash. I want to get rid of it, throw it to the ground. But I have grams here. The grams are what I want. Grams are good. Grams are something I would put somewhere nice, like up on a shelf to admire it. So this isn't written right. I want moles on the bottom and grams on the top. So in order to fix this, there's a flip tile button. And oh, look at that. Right away, it shows me that my moles have canceled out. It draws those lines for you. So you need to make sure that all the lines are crossed out that you don't want. All the lines are crossed out of those units that you don't want. And the show units shows me that I'm ending with the correct units, which is grams of carbon. If you go to the module page of our Canvas classroom, I have 2 additional items for you to see. I have given you 3 different PDF worksheets. They're old homework assignments. The first one is converting between molar mass and moles. So there's additional problems that you can practice on there. I also have another conversion worksheet, which is not really focused on moles and mass, but it is focused on 1 and I think a few 2-step conversions. And then I have a very challenging weird conversion sheet if anyone is really daring and really wants to push themselves with very nonsensical units like nuds and sock squared. You don't have all the conversions you need. You actually have to figure out some of your conversions. So those 3 are there. There's not an answer key posted, but any teacher would be happy to go over the answers and solutions with you during a support period. And I've included a PDF, which is a bit of a reference sheet for you if you're unfamiliar on how to use scientific notation with your calculator. This goes along with graphing and scientific calculators. It's also somewhat helpful if you're using a cell phone scientific calculator or our online Desmos scientific calculator. So remember, you need to try and finish your Gizmo Part C by your next class on Thursday or Friday. If you're feeling stuck, please come in and see us during our Wednesday check-ins. The official time for science check-ins are 1:50 to 2:30 in the afternoon. However, if you send me an email to my MCPS Gmail, there's a good chance I will see it within about 5 minutes, and I will be more than happy to join you in a Zoom office hours. I would also like to warn you guys that there's a very good chance you will have a molar mass checkpoint Thursday and Friday in class. It's pretty short, and as long as you have an idea what you're doing, I think you guys will do well. I hope it's an opportunity for everyone to make some points, and hopefully no one will lose any. Until I see you guys again, Be safe and make good choices.